Hello students, today we'll study the chapter motion and this is lecture 7 where we will discuss regarding the gravitational force. That means what is the effect on the motion. That and another thing we will discuss, that is the circular motion. Okay, so here just a minute. So motion of a body under uniform acceleration due to gravity. Here we will discuss two cases. First one, suppose this is the height and this is our ground and you are just throwing one ball towards this ground. So at that time, what will be the acceleration? And another condition we will discuss, that you are standing on the ground and you are throwing a ball to a certain height. So these two conditions we will discuss here. So for the first case, when you are throwing the ball from a height to the ground, at that time what will be the acceleration? And the second condition, that is you are on this ground and you are just throwing one ball upward. Okay. So at that time what will be the acceleration due to gravity? And another thing we'll discuss, that is the circular motion. That means if one object that is following, suppose this object that is following this circular path, at that time what will be its circular motion, what will be its velocity, what will be its speed. So all these things we'll discuss. Okay. Now, like whatever I have that discussed, that is motion of a body under uniform acceleration due to gravity. So if a body falling downward, that means from this height, suppose body means object. Okay, it may be ball, it may be in its stone. So this is the body. So if a body is falling downward and this may be ground or this may be surface of river water. So something you are just throwing downward. Okay. So at that time, what will be your acceleration? Here, if I am just throwing one particle, that means the initial velocity, that will be 0 and it is denoted by u. The initial velocity equals to 0. And we have seen this whenever we discussed the laws of motion. And at that time, what will be the acceleration? That is plus g. And g, you know that the acceleration due to gravity. And it is plus 9.8 meter per second square. Plus 9.8 meter per second square. Sometimes it may be they are giving g equals to sometimes in your numerical you can see that g equals to 10 meter per second square. Okay, at that time you have to take 10 meter per second square. But if they are giving plus 9.8 or minus 9.8, so at that time you have to consider this one. And some of the cases you will face where g is not been declared. So better you remember this gravitational acceleration. The acceleration due to gravity, you have to remember this thing. Okay. So this is the first condition where you are just throwing a particle from a height downward. And another condition is that you are, sometimes you can see this game already we are playing, that we are on the ground and we are just throwing one particle towards upward, that means towards sky. So it will go certain height, and with how much acceleration it will go, that is our minus of g. With this amount of acceleration, it will move towards upward, right? And whenever it will reach some height, at that time, the final velocity that is denoted by v, that equals to 0. The final velocity that equals to 0. So remember one thing, whenever we are moving, the particle is moving towards gravity, at that time plus g. Whenever it is against gravity, at that time you have to consider minus g. Okay. Next, one numerical regarding this we will solve here. The question is that to estimate the height of a bridge over a river, a stone is dropped. A stone is dropped freely in the river from the bridge. Okay. So here, this is the bridge. This is the bridge. And from here, there is some river here. So you are throwing one stone. You are throwing one stone. So this will cross this much height. It will take 2 seconds. It will take 2 seconds to touch the water surface in the river. Calculate the height of the bridge from the water level. Calculate the height of the bridge from the water level. Just a minute. I am just changing the color of the pen to solve this problem. Just a minute. Okay. So here, so what we have to take, that since the stone you are throwing from a height, that means from the bridge, so the initial velocity that is denoted by u, that equals to 0 meter per second. Okay. And the time taken, let it be denoted by t, that equals to 2 seconds. That equals to 2 seconds. So first, whenever you see any numerical, at that time you have to consider what are the given data you have in your hand. Then you have to consider what are the parameters you have to find out. So it has been given initial velocity equals to 0 meter per second, because whenever it is on the bridge, at that time it is in the rest condition. Now time taken is 2 seconds. So it is moving downward, that means towards gravity. So here the acceleration that is denoted by a, that equals to plus g. Here it has been given g 9.8 meter per second square. As I have told you, sometimes they are giving this value, sometimes they will not give you any value. So better you remember this thing. So plus g 9.8 meter per second square. Okay. Now what we have to find out? So we have to find out the height of the bridge from the surface of water. Okay. Height of the bridge we have to find out. Now we have studied the second equation of motion, where the distance is denoted with respect to or expressed with respect to the initial velocity and time. S equals to ut plus half a t square. Okay. So this was the equation, second equation of the motion. Now u is how much? Initial velocity 0. Time is how much? 2 seconds. So you can write half a acceleration, that is plus g. So 9.8 meter per second square, and t square, that means 2 square. So here you will get, after simplification, 19.6 meter. Okay. That means this height, that is the 19.6 meter. This height, the distance between the surface of river water to the bridge, that is 19.6 meter. Okay. So all of you understood? First you have to write what are the given data, right? So here first you have thrown the stone, that means the initial velocity equals to 0, time taken t equals to 2 seconds, acceleration already given, but it is a hidden thing that you are throwing that stone from the bridge, So in this line, it has been said that your acceleration is plus 9.8. So you have to find out the height of the bridge. Then you have to choose which equation of the motion you can use here, because here they asked for the distance between the bridge and the surface of the water. So we have to use the second equation of the motion. Okay. Let's move to the next one. When a ball is thrown vertically upward, fine. So this is the height, and from here some person is throwing one ball and it goes through a distance 19.6 meter. That means how much height? How much height? 19.6 meter. 19.6 meter, this much height the ball crossed. Find the initial velocity of the ball and time taken by it to rise to the highest point. And highest point is what? At 19.6 meter, right? So here what are the, let's find out the solution. Let's find out the solution here. So here maximum height reached, that equals to 19.6 meter. Okay, and the final velocity, always we are denoting with the help of v, that equals to 0 meter per second. And acceleration, your ball is moving against gravity. So acceleration here, that is our minus g. That means minus 9.8 meter per second square. In this problem, you can see that no g value has been given. So you have to remember this thing always. Okay. Now what I have to find out? We have to find initial velocity, u equals to how much, and time equals to how much, right? How much time has been taken and what is the initial velocity and what is the time taken. Okay. So first we are, let v square equals to u square plus 2as, laws of equation. Here if we put all the values, final velocity is 0. Initial velocity we have to find out 2, and here minus 9.8. S is the distance, that is 19.6 meter. Okay. So you can find out from here u square plus 2 minus 9.8. For the time being, I am just not writing the units. So u equals to, after solving this equation, we'll get 19.6 meter per second. Okay, 19.6 meter per second. Now, so here the initial velocity, the first question we found, the answer of the first question, that is initial velocity equals to 19.6 meter per second. Now for the second one, that is the time. First equation is v equals to, first equation of motion, v equals to u plus at. V is the final velocity is 0. U, now I know that 19.6. A, that is minus 9.8, and t. So after solving this t, we will get 2 seconds. So answer, here you can write down the initial velocity is 19.6 meter per second, and time taken is 2 seconds. Okay. So this one. Next, what is circular motion? Circular motion is described as a movement of an object while rotating along a circular path. Let me take the highlighter here. So here, the circular path, this is very, very important. This one, circular path. And circular motion can be either uniform or non-uniform. During the uniform circular motion, the angular rate of rotation and speed will be constant, and non-uniform motion, at the time of non-uniform motion, the rate of rotations keep changing. The rate of rotations keep changing. Okay. So the first thing, just a minute, I'm just taking the pointer. Okay, pen. Now, circular motion, that means the path is circular and your car, maybe you are just driving the car along this path. So this is the circular motion, and we can see the circular motion whenever you are driving the car following this circular path. So this is the circular motion, and you can see uniform circular motion and non-uniform circular motion. So what are the types of circular motion? Let me change the ink color. Okay. So here, first one is the uniform circular motion. Uniform circular motion. This is the uniform circular motion. Here, the angular rate of rotation will be constant. That means, if this is the center, and let it be your angular d omega by dt. Okay, d omega by dt. With respect to time, what will be your rate of change of this angular rate? That will be constant. And for non-uniform motion, that means I am not maintaining non-uniform circular motion. I am not maintaining the constant rate of rotation, constant angular rate of rotation or speed. Now, examples of the circular motion, we can see some man-made satellites we are just placing that revolves around the earth to get all the information regarding the earth, physical or some geographical information it will give us, right? So these man-made satellites, always it will revolve around the earth. So this is a very good example of the circular motion. And another example that is always you are using in your daily life, that is the ceiling fan. Whenever you are just seeing upward, whenever you are sitting in your home, you can see your ceiling fan is also rotating. And moving cart's wheel, your cycle wheel also, it has some circular motion. The blades of the windmill, the gears in the gas turbines, these all are circular examples of the circular motion. So now, angular variables, angular displacement. First is the angular displacement. Now, here you can see that this is the circular path. This one is the circular path. Okay. So, it is defined as the angle turned by the rotating particle per unit time. That means it is represented by del theta. Here you have the del theta. What is the del theta? Previously I was in this position. Now I am at this position. So at this position. So how much angle you have changed? That is del theta, and it is in radians. So angular displacement measured between two vectors, that is r and r dash. So it will be measured between r vector and r dash vector. So here the angular displacement means how much your object that is following the circular path, how much your object is changing its angle, rotating angle. So that is per unit time, rotating angle per unit time. That is the angular displacement. Like whenever it will be linear displacement, how much distance from here to here, that is the linear displacement. But here it is not, the path is not the linear one. The path is circular one. So in case of circular one, what I am doing, whenever I am moving from this point to this point, I am just covering some del theta amount of radians, right? So if I will just cover the whole circle, then I will cover whole circle. At that time, it will be your displacement. So del theta, that means how much angle you are making here. So it is angular displacement. It is measured as the angle turned by a rotating particle per unit time. Now the angular velocity, it is defined as, just a minute, I'm just taking the highlighter. Okay, so it is defined as the rate of change in angular displacement of a particle in circular motion. So it is the rate of change in angular displacement, and it is denoted by omega. It is denoted by omega equals to d theta by dt, where d theta is what? How much angle you have crossed, right? And dt is what? That is the time difference between 2 points. I am explaining this one. Just a minute. I am explaining this one. Suppose I have one circle here. Okay. And this is the center. So now, this is the center. So whenever I am at this point, let it be T1. After certain time, I am here. That is T2. So dt, that is nothing but the T2 minus T1. How much time you have taken. And d theta, this is the d theta. That means how much angle you have covered. So the angular velocity, this is the rate of change in angular displacement, but it should follow the circular motion. Okay. And it will be expressed, just a minute, again highlighter. Okay, it will be measured in terms of radian per second. And always we know that if it is linear motion, velocity is the ds by dt, where ds is the change in the displacement and dt is the change in the time or time interval, time span. So velocity, so this is the linear case, linear speed or linear velocity, and this one is the angular velocity. Now, what is the relationship between linear speed and angular speed? Linear speed and angular speed. Here, the v equals to omega into r. Omega into r, where r is the omega into r, where r is the positive vector of the particle measured with respect to center of the circle. That means if this is the circle, this one is the center, and this was our r vector. This was our r vector. So this is the r vector. So velocity, that equals to our omega into r. So this is linear speed v, and omega is the angular speed, that is sometimes we are calling rho. So here that w, not w, that is omega into r or rho into r. Okay, where r is the position vector of the particle measured with respect to the center of the circle. Next, if a particle moving in a circular path, it has two components. One is the tangential. Now, what is the tangential acceleration? In every point of this, whenever one particle is moving along this circular path, in every point, the velocity, the angular velocity here, this will be the angular velocity, right? For every point. So this component of acceleration in the direction of the velocity of the particle, that is called tangential acceleration. That is called tangential acceleration. Here you have the V. Okay, so velocity, the component acceleration is what? This is the component tangential acceleration. This is the component of acceleration in the direction of the velocity of the particle. Direction of the velocity of the particle. And radial acceleration here, what? This is due to the centripetal force. Suppose this is the center. Suppose this is the center, and here also you have some force. So this radial acceleration is denoted by AR. Radial acceleration, this will be denoted by AR, and tangential acceleration will be denoted by AT. So radial acceleration, this is the component of acceleration directed towards the center of the circle. And this component causes a change in the direction of the velocity of a particle in a circular motion. Okay. So the radial acceleration, that is the V square by R or R omega square. Okay. So here two components of acceleration we have seen. One is the tangential, another is the radial. Tangential, that means the component of acceleration in the direction of velocity of the particle. And radial acceleration, it is directed towards the center of the circle. It is directed towards the what? Towards the center of the circle. Now, angular acceleration. This angular acceleration is defined as the rate of change of angular velocity of the rotating particle. Rate of change of angular velocity of the rotating particle. This is called angular acceleration. What is acceleration? That is rate of change of velocity. So here this is rate of change of angular velocity. Okay, and obviously it is applicable for the rotating particle. And the unit is the radian per second square. Radian per second square. So this is the angular acceleration. And this alpha, it is denoted by alpha, and alpha equals to d omega by dt. Angular, how much angle you have covered, and per how much time interval you have taken. Okay, so this is the angular acceleration. Now, types of circular motion. Already I have discussed that uniform motion, non-uniform motion. That means what? Suppose this is the circular path, and one particle always for 1 second, suppose this is the del theta, this amount of angle it will cover for 1 second. Again, for next 1 second, it will cover same del theta amount. So that is the uniform circular motion. One particle is moving along a circular path possessing a constant speed. Okay, that is the uniform one. And non-uniform one, that will not, it will be maintained, that will not maintain any constant speed. Now, angular acceleration. So here the velocity vector changes its direction at each point of the circle for tangential part. And the tangential component can be positive, negative value. In the case of non-uniform circular motion, and zero value in case of uniform circular motion. Okay, so here we know that the force, whatever acting here, that is centripetal force, that equals to mv square by r, where m is the mass of the particle and FCEN, that is the centripetal force, and it will be directed towards the center. It will be directed towards the center of the circular path. So here we can see that angular acceleration during the circular motion, the velocity vector changes its direction at each point on the circle, and this implies the radial component of acceleration, which is always non-zero, right? So if your particle is here, then this will be the vector. That means it is changing its direction. If it will be here, then it will be the vector. If it will be here, then it will be the vector. That means for every position of the particle, the velocity vector changes its direction. So here, this is the radial component of acceleration. Now, let's solve some numerical here, where, let me take another color of the pen. Let's make the solution here. What is the angular velocity of a particle in a circular orbit rotating at the rate of 200 times per minute? 200 times per minute. Now, this rate, let me express in terms of F, that is 200 times per minute, right? And if we convert it into second, then this will be 200 by second. That means this times per second. Okay. So what is the angular velocity? Omega, that is the twice pi f. That means 2 pi, sorry, let me take again the pen. Twice pi f. What is the f? 200 divided by 60. Okay, this much radian per second, because angular velocity unit is radian per second. So here you can find out pi is nothing but pi, that is nothing but 22 by 7. Pi is nothing but 22 by 7. So you will find out 20.93 radian per second if you solve this. Okay. So the frequency or the rotating, the rate has been given to us, and they have asked to find out the angular velocity of the particle. That means they have asked to find out the omega. Always I have told you, whenever some question will be given to you, first you have to check what are the given data, then you have to check what parameter you have to find out. What parameter you have to find out. Okay. So it will be easy for you. A bus is moving in a circular track of radius 1000 centimeter with a speed of 10 meter per second. A pendulum is suspended from the roof of the bus by a light rigid rod of length 100 centimeter. Find the angle made by the rod with the track. Here you can see that G has been given 10 meter per second square. 10 meter per second square. So there is some circular path here. And the radius is how much? This is the radius, this is the center. So radius is 1000 centimeter. So let's first write down the given data. Radius is denoted by R, that is 1000 centimeter. If we convert it into meter, that means 10 meter. The velocity, it has been given, denoted by V. It has been given 10 meter per second. 10 meter per second. So tan theta, that equals to V square by R into G. That means 10 square divided by R is the 10 meter and G is 10. So theta equals to tan inverse of, this will be 1, tan inverse of 1, that means theta will be 45 degree. Okay, so this one is the answer. Next, the minimum velocity with which the car driver mass transverse a curve of radius 150 meter and coefficient of friction 0.6 to avoiding that skidding. So minimum velocity. Now to find out the solution, mu equals to 0.6, that is the coefficient of friction. Radius is been given, the radius I am denoting with the help of r, 150 meter, and g, that is the 10 meter per second square. So here mv square by r, that is the mu into n, and n equals to m into g, that is mass and also into acceleration, gravitational acceleration due to gravity. So if we put the value substituting n equals to mg, we will get mv square by r, that equals to mu into mg. Okay, so m and m will be cancelled. Here v square equals to mu into g into r. So v equals to root over of mu into g into r. So if we solve here, v equals to how much? Root over of mu into g into r. Mu has been given 0.6, g has been given 10, r has been given 150. Okay, so this will be 30 meter per second. That means in answer we can write down the minimum velocity is 30 meter per second. Okay, 30 meter per second. This much for today. Thank you.